All right, people, welcome back to Project Soup Dog. I am Mark. I'm Eric. Yo, we have already assembled our bulletproof bottom end. Now remember, we're looking for 1,000 horsepower here, so we began by using Aries pistons, Carrillo connecting rods. This thing has got to be stout. It is ready to go. Today's show, we're going to put the cylinder head on. We're going to degree the cams, which would be really trick, and I'm going to start by installing these high-quality head studs from ARP. Now, while he does that, let me show you guys what we did to the cylinder head, because believe me, it is super trick. Check this out. We took our cylinder head and sent it to the best, Darryl Cox Racing. Now, Darryl and Jay Chrisley have poured it and polished the head, set it up for us here, and they have actually gone beyond flow bench testing and have gone to sonic testing the cylinder heads. In keeping with using the best products and materials that we can on Project Soup Dog here, we contacted Racing Engine Valves, REV, for all of our valve tray needs. Now, what they sent us was a dual valve spring, titanium locator and retainer setup here, and we went with 1mm oversized intake and exhaust valve. The intake valves are super trick. We got titanium intake valves here. Now, the titanium is substantially lighter than the factory or a stainless steel valve, and it's got a heat threshold of 1300 degrees Fahrenheit. The exhaust valve is also super trick here. It's a super alloy called Pyromat 31. It's got a heat threshold of 2250 degrees Fahrenheit. Now, both these valves are swirl polished to help promote atomization of our fuel-air mixture. Now, this is super trick because we've got 1mm oversized valves on both the intake and the exhaust. And we went from a single valve spring to a dual valve spring. You think that would all add up to weight, but with our exotic materials from Rev here, we've saved over a ½ pound in valve train components. That is a lot. Now, this is the actual head that Darryl Cox did for the Project Soup Dog here, and the valves are super trick, but the valve job is super trick also. Check this out. Now, we had Blake Gann do a full radius 30 valve job here, which opens up the area around the valve to promote more airflow into the cylinders here. The more air we can put into the engine, the more fuel we can put into the engine, the more power we can make with the engine, which, of course, is the ultimate goal of this whole project here. Now, here's a little tip for you Supra owners at home. If you're going to put head studs in here like we're doing today, you'll find out if you go to put the head on top of the engine without putting the washers in beforehand, they're not going to fit and you're going to have to take it off. So put an ample amount of grease on it, stick it down in there, let it sit there, put the head on with the washers on first. All right, we just put our head on. Now that head gasket, we're using a factory Toyota head gasket, and that by far is the most important seal in the entire engine, so we had to ensure that both mating surfaces were perfectly clean before we put this on. And now we got all of our hardware lubed up nicely, and we're going to start to install it and get ready to torque this head down properly. And this thing will be on for real. These fasteners that we're using on the cylinder head here, they have a tensile strength of 190,000 psi. And in order for them to be working at their maximum potential, they need to be torqued down to 70 foot-pounds. In order for our torque reading to be as accurate as possible, it's important that I try to hold back on the engine so that it doesn't move around a whole lot while he's torquing it down. This is really critical, being that this is the most important gasket pretty much in the entire engine. If this thing fails, our race day is over. All right, we've got our cylinder head on, torqued on nicely. Next step is to drop the cams in, and before I do that, I'm going to put some of this special lubricant supplied by Crower with their camshafts. And the idea behind this is it's going to have to sit on an engine stand for a little while before we go to start it up. And when we do go to initially start it up, it may take a minute or two before we get good oil pressure while we're cranking this thing. And if the lubricant was cheap, it would end up in the oil pan, and that would do us no good. We'd have metal on metal contact. No matter how many hundreds of times you do this, always consult the book, because you can never be too right. All right, so our crankshaft is on TDC. The marks line up here on the bottom. TDC number 1 cylinder. Exhaust cam is lined up with the top here. Intake cam is lined up with the top. There's no slack on the drive side, being that this engine spins clockwise. So this is the slack on the reverse side. It's taken up by the tensioner. We're going to pull the pin like a grenade, and that's it. We have tension, and our timing belt is in effect. All right, this is the good stuff right here. This is something that I've never seen on television before, and I've been watching automotive programs my entire life. We're going to degree an engine and show you guys what the hell we're talking about when we say degree an engine. And what we're going to do now is we're going to control the time when the intake and exhaust valves open and close in relationship to top dead center. Crankshaft is at TDC number 1. I have a little piece of welding wire right here on my degree wheel, which represents 360 degrees of crankshaft rotation. It's at TDC number 1. And the cam gears are stock settings right here, straight up and down. So we put everything on just the way it is, and we're gonna see when does this intake valve open up. In the United States, we always measure valve opening at 50 thousandths inches of lift. So while I sweep through here and the gauge starts to move, there's our 50 thousandths of lift. Now the valve is open 50 thousandths of an inch, been acted on by the camshaft. When is it happening? 5, 6, 7, almost 8 degrees after top dead center. The cam card that came with these stage 3 Crowler cams wanted this thing open, I believe, 8 degrees before top dead center. So we're way off. We gotta make a major change. If we want this to happen 8 degrees before top dead center, we're gonna put it 10, 9, 8 degrees before top dead center. Now we're gonna make a move on the camshaft. This is where I want it to open, 8 degrees before top dead center. So it needs to be advanced a lot. So unlock these jammies. How we do this is we put the crank where we want it, and we move the cam over to our 50 thousandths inches of lift. Where are we at? 5, 6, 7 degrees before TDC. I could move it another degree, but I'm gonna be happy with that. And that means that our intake cam is now degreed to the specs that the Crowler cams came with. So we're gonna move this rig now over to the exhaust cam. We're gonna do the same thing on that side. We're gonna see what we come up with. We're gonna get these guys dialed in perfectly. This is what we ended up with here. The intake valve is opening 7 degrees before top dead center. The exhaust valve is closing 5 degrees after top dead center. That's going to give us a time period of 12 degrees when the intake valve and the exhaust valve are open at the same time. Now this is happening right when the exhaust valve is about to close. The intake valve starts to open up, and what happens is the inertia of the exhaust leaving the cylinder head actually jerks a little clean, fresh air and fuel mixture in there, makes nice high-end horsepower. Might not be the most emissions-friendly setup available, but it sure is going to make us good horsepower. Details, our boy Brian Kono, who's got the bodywork under control on the car. He's been working feverishly trying to get that thing ready. We also sent a bunch of engine parts with him so we can paint those things. And he should be running through here any second now, bringing some cool stuff. And
hey, how you doing?
Brian Kono.
From After Hours.
Yeah. Oh, that is pretty, man. Let's see how this thing looks right here, man. Oh, that looks pretty.